Okay, so we're going to talk a little bit about Module 1, Lesson 3 today. This lesson's all about formulas, which are, math equations that, represent some fact, typically in science classes that we can use. This first one, for example, is a perimeter equation. P equals A plus B plus C. It's the perimeter of a triangle. So for this, we're going to solve for C, which means we want to get the C on one side by itself. And then they give us some values. They tell us that P is 32, A is 6, and B is 11. So our first step is to plug in the values that we know to the variables in this equation. And so we're going to start there. We're going to plug our 32 in over here. Our A is 6, our B is 11, our C is unknown, and that's okay because that's what we're solving for, so we won't necessarily know that. Once we get this substitution done, what we've done is we've made a one variable equation, kind of like what we did in lesson 1. We're going to solve for C, so we can start by cleaning it up. On the right side, 6 and 11 are like terms. We can add those. Okay, and then we're trying to get that C by itself on one side, so I'm going to move 17 over by subtracting, get rid of those, and so C is equal to 15 is going to be our solution. So we're working with formulas, but really most of the math is going to be the same algebraic steps that we've used in the first couple of lessons. Sometimes when we're working with these formulas, they won't give us values for any of our variables, and they'll ask us to solve in general for one of our variables. So this was an example of that. It asks us to solve for y. That means the same thing as what it has in all of our lessons so far in this course. When we are asked to solve for y, what that means is we want to try to get the y on one side by itself. But because we don't know what x is, we're going to have some x's left in our answer. We're going to have an expression and not just a single number solution to this. So that's okay. But we are going to follow the same process in that we're going to work towards getting that y on one side by itself. So I'm going to start here by moving the things that don't have y's over to the other side. I'm going to start by subtracting 3x from both sides. Okay, get rid of those. On the right side, these terms, the 18 and the minus 3x, these are not like. Okay, so we can't put those together. So we're just going to bring them both down as two separate terms. Remember, you can only combine with addition and subtraction terms that are like. These are not like. Okay, so we've got our y term on one side by itself. Our last step here is to get that 6 out of here, and it's a multiplication. So we're going to divide both sides by 6 to make that happen. I'm going to divide each term by 6. It would not be wrong to take this whole thing and put it over 6, but I like to do it separately because it does make simplifying easier, and it's also going to be very useful when we talk a little later in the course about these things called linear equations that we're going to be graphing. This is going to make this much easier to work with. So to simplify this down now, what I'm going to look at is well, can I reduce my fractions? This negative 3 over 6, top and bottom are both divisible by 3. So negative 3 divided by 3 is negative 1. 6 divided by 3 is 2. So negative 1/2 will be my simplified answer there. And then the second one, 18 divided by 6 is 3. And so we'll get a equation that's been solved for y. That's what we were supposed to do here. We want the y on one side by itself. We've done that, and we've cleaned it up as much as possible. And notice we do have two terms here. That's okay. When we're solving for these formulas in general like this, we'll often have expressions. Nothing we can do about that. One fairly common use for formulas in science classes is to convert between different units of measure. In this case, this is a formula F equals 9/5 C plus 32 that allows us to convert between degrees Fahrenheit and degrees Celsius. So we'll be using this formula in several problems in your homework. For this example, and the key to using this correctly is making sure you substitute your known value into the correct variable. Okay, it says here to convert 50 degrees Fahrenheit to Celsius. It's important to note that this 50 degrees number that they're giving us is an F value and not a C value. So we're going to plug it in for the F in our equation here. It'll look like this. Okay, and then we will go to solve for C. So our first step here is to start to collect our like terms. I have the C term on the right. I want to get all my constant terms and collect them on the left. So I'm going to start by moving this 32 on over. And get rid of these. So 50 minus 32 gives me 18. Okay, when we have fractions like this to deal with in the problem, there's several ways that we could do this. A lot of people remember you multiply by the reciprocal. That will certainly work. Kind of my philosophy is let's just get rid of the fractions right away by multiplying by the lowest common denominator of all of our fractions. When we just have one fraction like we do in this problem, finding the LCD is pretty simple. It's just going to be 5 since we just have that one denominator. If I take that lowest common denominator and I multiply it times every single term in this entire problem, all of my fractions are going to go away. So that's going to be my next step here. I'm just going to take this equation. I'm going to multiply by 5 on both sides. Okay. 9 times 18 is, or I'm sorry, 5 times 18 is 90. So it doesn't help us over there. We get bigger numbers. But on the right, this is where this really helps us out. That 5 on the bottom, 5 divided by 5 is equal to 1. So we can just cancel those 5s out, and we'll just be left with 9c, no more fractions. Multiplying through by those LCDs, if we choose them correctly, it's going to let us get rid of our fractions. And then our next step here is just to divide, and we'll get our c value. And that'll give us our Celsius temperature. Okay, so, but it is very important to note that because we were given a 50 degrees Fahrenheit, this is an F value. That 50 has to go in for F in our original equation if we want this to work out. If they gave us a Celsius temperature instead, we would have plugged it in for C instead, and then all of our work would have been on the right side of our equation instead. Okay, so let's look at one more example of an equation that we don't have the value for our variables. And this is a problem I wanted to work because I think this is one that people tend to make harder than it is. The first thing we need to note is what we're solving for. This one says to solve this equation for h, and that's important because h is what we're going to try to get on one side by itself. So if I'm going to solve for h, my first step is to get things away from the h. I want the h to be isolated on one side of the equation by itself. So that first term on the right side, 4WL here, no h is in that. So I just want to move that over to the other side to get started. So I'm going to subtract 4WL from both sides. Sorry, my handwriting. Forgot my stylus today, so doing this with my fingers, so doing the best I can. Hopefully it's still legible. And on the right side, when we're putting these things together, we just can't do anything because these are not like terms. Remember, when we're adding or subtracting these terms, they have to be like, or we just have to leave them separately. When these formulas that we're solving in general like this, we will very, very often have terms that are not like, and there's just nothing we can do about that. We're just going to leave them separate. That's fine. Okay, and so again, keep your eyes on the goal here. My goal is to get that h on one side by itself. Need to get rid of that 2w to make that happen, and this is just a multiplication on the right. To get rid of multiplication, we're just going to divide, and I'm just going to do the whole thing on both sides. I'll get rid of those. H is by itself. This is one of those problems that people tend to make very difficult and complicated when really, because we don't know what any of these values are, because none of our terms are like, there's just not much that we can do to simplify. Okay, so even though we have a lot of variables, it looks intimidating at first because we can't combine like terms, we don't have any like terms, just not much simplifying we can do, and that's the answer. That's the general formula that we would want here. Okay, so hopefully that's enough to help you get started with this lesson 3. Please let me know if you have any other questions.